Hello everyone, I'm Bingja. Welcome back to another video. So in this video, I'm gonna be talking about inequalities because originally I planned to include it in the last video, but the video is really too long, so I decided to bring it forward to this video. So yeah, without further ado, let's start. Inequalities. All right, inequalities, qualities. All right, I'm gonna make this board a little bit larger. All right. Inequalities here means that it's not equals, right? Just as the name suggests. So you will see a lot of lesser than, lesser equal, more than equal. All right. So you will need to know how to use inequalities to solve linear equations. All right. And then uh, from here you will represent it on a number line, all right? And then, or using a graphical method. All right, so in this video, I'm gonna be talking about all these, all these topics here. All right, so for inequalities, just as it suggests, it's something like, let's say y is lesser than 3. All right, then if y is an integer, then we know that y is equals to 2, 1, 0, -1, and so on. All right. So this is like if we are talking about x is more than 5, where x is an integer, then we know that x is equal to 6, 7, 8, and so on. So this is the very basics of the meaning of inequality. So first thing, we're going to talk about number lines. All right. Number lines are a straight line straight to infinity, where it goes from negative infinity right to infinity. All right. So this represents lesser or more, and this represents this or this. All right. So you might not understand what I'm talking about. So I'm give you an example. All right. E.g., I would say x is in between -3 and 2. All right. And if you are to represent this on the number line, all right, the number line here, it starts from -3, -2, -1, 0, 1, 2, 3. All right, I'm gonna extend one more to -4. So how are you gonna represent x? All right, so x firstly is larger than -3, right? And if you notice here, there's no equal sign here, so we are using the empty dot. All right, so from -3 here, we're gonna draw an empty dot here. All right, and the second part here, x is lesser or equals to to 2. All right, so we can see that a full stop dot is equals to is representing the sign with equals, so it will be a whole filled dot. All right, and then we will just connect these two dots with a straight line. Yeah, it's definitely not straight here because my hands are shaking. So yeah, this is how you represent it in a straight line. All right, so this is about number lines. And for graphical, all right, graphical methods, you will need to know something, the area which represents larger or lesser than. All right, for graphical, it's in a graph of y and x and 0. All right, so you need to know the difference between a single line, all right, if it's a single line and a dotted line. All right, so what are the difference between these two lines? So if you have a line that is a solid straight line, this represents lesser equal or more equal. Then if it's dotted, then it's lesser or more without the equal sign. All right, so let's look at some example. All right, if I'm talking about y lesser than x. All right, and x is more than 3, more or equals to 3. So you are to graph these two graphs on this line, okay, y and x. So before you graph these, you are gonna graph, all right, so here you need to plot, not plot, it's to sketch. You will need to sketch y equals to x and x equals to 3. All right, so y equals to x is this line over here. All right, and x equals to 3 is this line over here. All right, this is 3, this is 0. Okay, and this is obviously something that we will look after that. So at here, this is equals to y equals to x, and this is x equals to 3. All right, but from the first part here, we see that if it's lesser or more than, we are using dotted lines. So at the y lesser than x line here, we are supposed to use dotted lines. All right, so we are going to use dotted lines. Okay, so this is how you represent y lesser, y equals to x and x equals to 3, but you are not done yet. All right, because these are just the equations of the line. So now you need to determine the area. All right, so first y must be lesser than x, which means everything up here is y more than. All right, I'm gonna use a different color. Let's say this. All right, everything up here is called y larger than x. Therefore, we shade away the regions that we don't want. All right. And then for x larger or equals to 3, all right, which means all the area here is our x smaller or equals to 3. All right. Therefore, we have the region R here is the region that we want. All right. So the region complies of all this to infinity. All right, so this is an example of a graphical method to graph out the inequalities. Okay, so we're gonna look at the examples here. All right, solve each of this inequality and show the solution on the number line. All right, and then I will add this. It's okay. We will show it on the number line. All right, draw with touch. Okay. Firstly, we have 14 minus 3x lesser than 7 plus 4x. All right, so if we are going to move the unknowns to a side and the inequalities to the other side, we have negative 3x minus 4x lesser than 7 minus 14. And you get this one, negative 7. All right, so there's one thing to take note here. All right, I'm going to go back to this part. All right. Note that if you have negative a lesser than negative b, right, when you move negative to the other side, this must change to this, vice versa. All right, so if whenever you have a negative sign that you need to move to the other side to make it positive, your operand here, your inequality here must change to the other one. Okay, so this will be equals to a larger than b. All right, so if you want to know about the theory behind this, you can actually think let a be 2 and let b be 1. All right, so negative 2 is lesser than negative 1. That makes sense. So if a is 2 is larger than 1. All right, so you see how it goes, why the sign must change. All right, so it works every single time. You need to take note of this. So back to this. when you have a negative here, all right, when you have a negative here, this is a negative, so you bring it over, x must be larger than 1. So this is the answer. All right. So now we're going to look at the, all right, before that, we need to represent this on a number line. So on a number line, this is 0, this is 1, 2, 3, and so on. So what you need to do is an empty circle followed by this. All right, so this is how you show it on the number line. All right, the second one, we are going to show it. Let's do the second one. More space. Okay. 2x plus 5 is larger than 1. And 3x plus 4 is larger than 7. So from here, we will solve that this is equals to negative 4, x is larger than negative 2. And from here, we get that 3x is larger than 3 and x is larger than 1. All right. So from this part here, after we conclude from here, we are going to draw a number line. All right. So this is negative 3, negative 2, negative 1, 0, 1, 2, 3. All right. So we are first going to plot this. X is larger than negative 2. So we have a blank and empty one here. And the second one is x is larger than 1. All right. X is larger than 1, which makes x must be equals to this part behind. Because the question didn't state that x must be an integer. So anything 1.01 can be the answer also. All right. So this is just that easy. So to the next one. All right, at this last part of the question, we have here 3x is lesser or equals to 2x minus 1 and 7x is more than 4x minus 9. So we will group both of the x's to one side, all right? Usually we group them to the left-hand side and we'll start to solve them. X is lesser or equals to negative 1 and 3x is larger than negative 9 and x is larger than negative 3. Okay, so if we are to represent this on a number line, okay, some spoiler for the next video. All right, if we are to represent this on the number line, all right, so from here we have negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So for the first part here, we have x is lesser or equals to negative 1. So we have a full stop here and we go all the way to negative infinity. And the right side here, we have x is larger than negative 3. So it's an empty one and goes to the positive infinity. And therefore, we know that this is the answer that we are looking for. All right, therefore, x is in between negative 3 and negative 1. All right, so this marks the end of the video for linear inequalities. For the graphing part, I will talk about it more when it comes to the graph in the very future video. It's in the syllabus too. So we are gonna look more about the graphing at that moment. All right, so for now, this is all about the inequalities that you will need to know how to solve the inequalities and how to present it on a number line. So yeah, that's all. I hope you guys will understand this, and I will see you guys in the next video where we will be talking about the nth term, and that's one of my favorite subjects in maths. All right, so thank you for watching. Stay tuned.